Hello everyone, my name is Hassan and today I'm going to be giving you a small demonstration about analog to digital conversion. Let's delve straight in. I try to make a small visual illustration by myself. I hope that suffices. So anyway, the first thing that you need for analog to digital conversion is your analog signal, and that comes with your audio input. Over here you're seeing a mic and you speak into it, sing into it, and you generate an signal that goes into the speakers. And then there's this analog to digital conversion which allows you to hear back your whatever you have recorded from your CPU. Yeah, I wonder which version is that, but anyway, uh, this is the conversion which we are interested in. But firstly, we need to realize why this is important. Generally, our computers basically cannot read those the wave inputs that we are sending in through the our audio signal, our audio instrument. So what we do is we need to convert these into something that the computer understands, and that's basically called a bit. A bit is basically comprises of, I'll write over here, a 1 or a 0. Either 1 or a 0. This is one bit. This is like one memory location inside the computer, and a stream of ones and zeros, or a collection of bits, is called a word. And the length of a word is basically denoted by, over here we can see, 2 to the power n being the number of bits there are, and 2 to the power and 7 bits, basically a 7-bit words, a collection of 7 bits. The word with the length, with that length, is basically used in our MIDI. So 2 to the power 7 is basically the word length that we can get from our MIDI input. That was just an example. So what we do is, when we have that audio signal, we have 3 stages we have to take care of. We have to take care of the sampling rate, the quantization, and the encoding. In the sampling rate, we basically define uh, the number of measurements in a specific period of time. For example, we might take 44,000 samples per second, which is something we use in the studio generally. So what we do is, you can note the amplitudes of these waves, and we take the amplitude, we note them, and then we store these amplitude, and we quantize them, we assign them values. Like the wave with the higher amplitude gets the higher value. It got 7. This wave has a very low value. It's a 2, then a 5, then a 7 again, 4, 3, and 4, and so on. The wave goes on. We take a specific number of measurements per second, and then we assign them quantized values. And how we use these quantized values is we convert these quantized values into binary numbers. Like 7 in binary is 111, 5 is 101, 3 is 011, 4 is 100, and for any quantized value we can convert them back into the binary form something. These are the streams that the computer can understand. So in the encoding phase, we basically assign these values, binary values, to each of a quantized value. We get a whole range of these values, and these are fed into the computer, which can then process them and display our desired output, and which is the audio signal itself. Uh, so that is basically the whole entire concept of analog digital conversion. Of course, you can play around with the sampling frequencies. The Nyquist frequency is really important in this regard, which is the half of the sampling rate that you have to take in accordance when you're doing this conversion. You also have to take care of the frequencies and the amplitudes you're using. You don't want a very high sampling rate or very low sampling rate, and differing sampling rates can of course affect your audio output as well. So with that, this is just an intro of sorts, and I hope this was helpful for you. And I'll see you next week with something new to showcase. Okay, this is Hassan signing off. See you next time, guys. Bye.